Yeah. Wow. Okay. ये पासवर्ड है अरे बंद हो गया अरे मुझे और सुनने का
ते तो कॅमेरा का दिसत नाही बघ बरं
अरे देना अरे देना
कोण पिघला नाही देतो ना पिघला नाही
मारना है जस्ट चेक करना है चेक करने सिर्फ मैथ्स कौन कौन है nothing going on. हाँ? चप्पल दिखा रहा है वो. चप्पल दिखा रहा है वो.
अरे दिखा रहा है दिमाग के साथ तो काट कर इलाज करवा रहे चाहिए ठीक
Hello.
Hello, sir.
Sit down. Where did we stop last lecture?
My birthday was there yesterday.
Oh, happy birthday to you. It was all okay.
14.
Motion in one dimension. We had started? No? क्या कर रहे थे बताओ? तो started होकर नहीं खत्म होने आया। अच्छा। Okay, so you have to tell me where did we stop in the last class? But no graph. Okay. Let me You have done which topic? Graph of which topic you have done?
Sir, if you were doing numerical statistics.
Shape was in first chapter, not in this chapter. Shape से बाहर आ जाएगी. Okay, velocity time graph we had completed.
Yes, sir.
We had completed velocity time graph.
सर अभी वो ये कर ले केसेस
कौन सा cases? Case 3 किया था?
सर केस
Online student.
Yes, sir.
In case 3 we had done ना?
Yes, sir.
आराम से जरा आराम से इधर आके बैठ. You come here with your notebook. नहीं बैठ. Sit near the door so that I can send you out. इधर आके बैठ.
नहीं है
क्या है
ना ये हाँ है ना है
अरे एक ही है
Okay, so now let me start with case 3 again. Inside towards the wall. So what is the graph in case 3 tell you? What is happening till 6 seconds and what is happening after 6 seconds? Further, sit towards the wall.
Okay.
So that you don't block our view. So question is, what is the nature of motion in the first 6 seconds? See the graph. Where are you seeing the graph? Page number 20.
Increasing in
Case 3. What is the graph like? Graph is like
Displacement is balanced.
1, 2, 3, 4, 5, 6. This is the graph, and you have 2, 4, 6, 8, 10, and 12. And this is displacement. And the graph shown is
Triangular.
okay. So what information does the graph give you on the board?
The displacement is velocity is 0.
So first of all, it is a ST graph, right? What kind of graph is this? What is displayed on the y-axis? Displacement. So this graph is ST graph. So what information do you get from the graph? One is the nature of motion. What do you get?
Nature of the
Nature of motion. So you can see that the graph has one type of motion till 6 seconds. So what is the nature of motion? What is happening for 6 seconds? Yuvari? What is happening?
Has reached
It has reached what? Is it a straight line graph?
balanced.
So straight line graph means what? What kind of motion? Uniform motion. What kind of motion?
Uniform motion till 6 seconds.
Yes. And what about? So what is?
Uniform motion from 6 to 12 seconds.
So uniform motion. But what kind of uniform motion? Huh? Positive what? Positive slope. What is the slope? Slope is positive.
in 6 seconds.
Yeah, till 6 seconds. Okay, and it is a straight line. So slope is same for the straight line. This is what we had learned in the last class. And what does the slope of ST graph gives you? Velocity, right? So is the slope positive?
Yes.
Therefore, velocity also will be positive, right? So slope of ST graph is equal to
Positive.
velocity. And how do you calculate the slope? What is this point? 40. This is 20. So this is, let us say, V2. So this is S2. What is this point? S2. Final displacement. This is initial displacement. And what is the corresponding time here? This is T2 final time. This is T1. How you calculate slope? How you calculate slope?
S1 minus
So this is S1 minus S2 or S2 minus
S2 minus S1.
divided by T2 minus T1. So what do you get now?
20 by 2.
So this is 40 minus 20 divided by
4 minus
4 minus 2, which is
10.
10 meter per second, and this is plus So the direction of motion is given by sign of velocity. That means the motion, the body is going away from the origin. It is going away, right? And what was the nature of motion? Uniform motion. So each second, right? How much distance the object is traveling? 10 meter. That's why it is uniform motion. 10 meter per second. So every second you can see when you go from here to here 1 second. At 1 second, it is covering how much? 10 seconds. That's why straight line. Is that clear? So these two information we get from displacement time ground. Now, what is the nature of motion after 6 seconds? What is the velocity? Minus 10, right? Therefore, if you extend this, and let us say we take it between 8 and 10 seconds. So what do you have? What do you have? So now T2 is this. Always the final time is the later or greater time. So corresponding to T2, now we have S2. This becomes my S2.
Same answer.
And this becomes S1. How same answer?
Same.
Yes, sir. What is S2?
First cycle.
What is S2? 20. Sign तो change हो गया. So 20 minus 40 हो जाएगा. तो answer same as plus 10 is not same as minus 10. Because the directions of what is the direction of motion? Opposite for this. Here it was going away to 10, 20, 30, 40, 60. It was going away. But in this case, the object is returning back to initial position. Okay? So object is returning back. So it is uniform motion, but in the opposite direction. Is that clear? The sign of velocity tells the direction of motion. Is that clear? So if we name any object, so let us say name the graph. So from A to B, object is going away from origin, and from B to C, it's coming back to origin. Is that clear? Mind you, this is the graph for motion in a straight line. Let's say this is, if initially object was going like this. Okay, so this is 20, 30, 40, 50, and 60. So this is A to B. A to B motion is like this. E was equal to plus 10 meter per second. And how much time it took? 6 seconds. Then it is returning to A. This is E is equal to minus 10 meter per second. Understood? The motion is on the straight line only, but away and towards. Okay. Now next is, let's look at case 4. What kind of graph it is? Case 4 is, it is again displacement time. So what is it? Same. Is there any difference? This graph between
Uniform
A
velocity.
because its का slope क्या होगा? Straight line ST graph means uniform motion. And what is the characteristic of uniform motion?
It does not change.
Constant slope or B equal to constant. Like V is 10 only throughout the motion. Uniform motion में क्या होता है? क्या change नहीं होता? Velocity. तो velocity कौन बताता है? Slope. और straight line का slope चाहे ये दो point पे निकालो, चाहे यहाँ पे निकालो, any two point you take on the straight line. Is it slope changing? Is it inclination changing? No. तो straight line का slope हमेशा same होता है. That is slope of ST graph is equal to constant. We are saying the same thing in different way. Slope is graphically. V is when we calculate the slope. Clear? So this is also uniform motion. Case 5. Now I change the graph like this. Now what is happening? Is it a straight line? No. So it is a non-uniform motion. What about slope?
Non-uniform slope.
Slope is always the tangent at that point, right? यहाँ पे एक tangent बना, यहाँ पे इसका tangent बना, यहाँ पे इसका tangent बना. You see everywhere the slope is increasing, the angle is increasing. So whenever you have a curve, then it is not constant slope. Slope is changing everywhere. Okay? That means velocity is changing. Slope changing means what is changing? Slope indicates velocity. If velocity is changing, then accelerated motion. What kind of motion it is? Accelerated motion. Is that clear? Is it uniform motion? No. Okay, so it is non-uniform. Non-uniform. So therefore, is velocity constant for this? No. No. What is happening to velocity? You can see that the slope is increasing. So velocity is increasing. Velocity is increasing with time. समझ आया? ग्राफ देख के तुमको समझ आ रहा है कि velocity of the object is increasing with time. Okay? Right?
So, sir, if in the previous graph also the velocity was increased,
No,
means whether it is constant.
it is constant
Means,
because the slope is constant. Slope gives the velocity, na?
okay.
So, bolo.
Too much curve indicates that it is the speed is increasing
Yes,
at a
yes.
faster rate.
Yes. No, yes. If the slope is not uniform, that means velocity is changing. But how the velocity is changing? You can actually calculate the velocity at different points. Okay, then you can find the difference. If the difference between 2 points is same, then velocity is increasing at a constant. Then the acceleration is constant in that case. Got it? So this is what it is. Now, how do we calculate velocity between any 2 points on the curve? How do we calculate velocity between any 2 points on the curve? यहाँ पे A और B के बीच का velocity निकालना है, average velocity. This becomes x2. This becomes x1. What is x2 and x1? Value of displacement at different points. Okay, this is distance, right? So distance is, how do we represent distance? By position. Position is x. Okay. Like यहाँ पे क्या है? ये x1 हो गया, ये x2 हो गया. I know different values of positions in meter. और ये क्या हो गया? T2 and T1. What is the slope here? So E average equal to x2 minus x1 divided by T2 minus T2. So there is a concept of instantaneous velocity. I have taught you. Remember instantaneous velocity? Velocity is shown by the speedometer. It's always instantaneous. So if you calculate the velocity, the slope of the tangent, that gives you instantaneous velocity. But when you calculate velocity between 2 points, that gives you average. Understood? Yeah. First of all, you have to know, have we discussed what is instantaneous velocity and
Yes.
average velocity? Suppose the ST graph is like this. Okay. Let us say we have 3 points A, B, and C. Right? What is the average velocity between A and C? This will be calculated by you got to find the slope. Average velocity between B and J is you need to find this. Join this two lines. Take a straight line here. So this will be what? X to X1. These are the values of displacement on the y-axis. This is x2 minus x1. Change in y-axis. And what is this? This is T2 and this is T1. So what is this difference? So B average is calculated like this. So on the curve, you take the slope between 2 points, any 2 points. That gives you average velocity. Why average? Because during the journey from A to C, the velocity is not same. Velocity is changing, right? So the average velocity is calculated like this. This is a straight line. Now if I wanted you to calculate what is the velocity at B, at that instant. अभी तो एक ही point है ना?
So we have to calculate A, B and B.
A, B and BC नहीं. मान लो while going from A to C, we know that velocity is changing continuously.
Yes.
If I want to know exactly at B what is the velocity, जैसे तुम गाड़ी चला रहे हो, तो speedometer में you have the pointer. So the moment you look at the speedometer, you know that what is the velocity of my vehicle right now. वही तो होता है instantaneous. So how do I calculate instantaneous in this case? You take the slope, yeah, you calculate the slope of the tangent. यहाँ पे tangent बनाओ. Okay? You have a tangent. So tangent का तो slope कहीं पे भी किसी भी point पे same ही होने वाला because it is a straight line. और एक point at one point there is only one tangent possible. Correct? So treating this tangent as the straight line, I will now mark 2 points here. I'll calculate the slope of the tangent. Understood? So instantaneous velocity. Instantaneous velocity. कैसे calculate करते हैं? Slope of the tangent. At that time. मतलब B किधर है? B का टाइम क्या है? ये है ना? This is time for B. वहां पे एक स्लोप बना दो, सॉरी वहां पे एक टेंजेंट बना दो और उस टेंजेंट में कोई भी 2 पॉइंट चूज करो और उसका स्लोप निकालो. करेक्ट? Choose any 2 point on the tangent, then उसका difference in y-axis divided by difference in time. Got it? समझ आ गया? क्योंकि कर्व पे अगर निकालोगे 2 पॉइंट का तो वो आएगा एवरेज वेलोसिटी, लेकिन टेंजेंट पे निकालोगे तो वो आएगा वेलोसिटी एट दिस पर्टिकुलर टाइम. ठीक है? नहीं समझा? क्या नहीं समझा? इंस्टेंटेनियस वेलोसिटी कैसे डिफाइन किया था हमने? Distance covered in a very short small time interval divided by the time interval. तो लेकिन अभी ये पॉइंट पे तो टाइम इंटरवल नहीं मिलेगा ना, एक पॉइंट पे तो एक ही टाइम मिलेगा. तो वहां पे हमने क्या किया? टेंजेंट बना दिया. अब उसका स्लोप फिक्स हो गया. टेंजेंट का तो स्लोप फिक्स हो गया ना उस पॉइंट पे. तो टेंजेंट मान लो ये टेंजेंट है मेरा, तो इसमें मैं कोई भी 2 पॉइंट चूज करूंगा, मेरे को y पे एक वैल्यू मिलेगा, दूसरा वैल्यू यहाँ पे मिलेगा. मान लो मैंने ये 2 पॉइंट सेलेक्ट किया, टेंजेंट है ये जो मेरा टेंजेंट है, इसमें मैं 2 पॉइंट सेलेक्ट करूंगा तो क्या मिलेगा? ये मिलेगा ना y एक्सिस पे और इसका करस्पॉन्डिंग x एक्सिस पे मिलेगा। वही तो बता रहा हूँ मैं। इंस्टेंटेनियस वेलोसिटी निकालने के लिए अब वो जो टेंजेंट है ना उसका स्लोप निकलेगा। समझ आया? क्लियर? तो ये हो गया इंस्टेंटेनियस वेलोसिटी। कर्व में दो चीज निकलती है, एवरेज वेलोसिटी और इंस्टेंटेनियस। और यूनिफॉर्म मोशन में एवरेज वेलोसिटी और इंस्टेंटेनियस वेलोसिटी सेम ही होगा, क्योंकि वेलोसिटी चेंज ही नहीं हो रही किसी भी पॉइंट। बात समझ में आई? यूनिफॉर्म मोशन में एवरेज वेलोसिटी और इंस्टेंटेनियस वेलोसिटी सेम ही मिलने वाली, क्योंकि वो चेंज ही नहीं हो रहा उसका स्लोप। ठीक है? अंडरस्टूड? तो 6 में एवरेज वेलोसिटी निकाला है, 7 में इंस्टेंटेनियस वेलोसिटी निकाला। ठीक है? तो उसने छोटा सा टाइम इंटरवल लिया है। वो छोटा सा टाइम इंटरवल अगर हम लेंगे तो ये ग्राफ क्या होता है, छोटे टाइम इंटरवल में ऑलमोस्ट स्ट्रेट लाइन हो गया। छोटा सा टाइम इंटरवल लेंगे तो ग्राफ क्या हो गया, स्ट्रेट हो गया। तो इन दैट शॉर्ट टाइम इंटरवल द स्लोप रिमेन्स फिक्स्ड, दैट्स द assumption. You get it? Read case 6 and 7. Read it. Read it. Read case 6 and 7 and ask me if you have any question. यहाँ पे इस लो Understood. Understood. Same thing what I told. So with this we have completed all the ST graph. Now we'll come to, now look at example 6. Quickly discuss example 6. So read everybody. I'll draw it on the board. So this will make it more clear. You will have questions only for straight line. Curve questions will not be there. Okay? You will have only questions on straight line. Curve question will be like qualitative. You will not have numerical on the curved question. Numericals will be only on straight line. Okay. So what is given here? Look at example 6. So draw the displacement time graph with its help. So you have given the time values and the displacement values. So immediately draw the graph. Time on x-axis. So what is the first point? Time, when time is 0, right? Distance is also 0. So this is the first point. When time is 1, distance is 10. So what is the point here? Likewise, 3, 4, 5. 20, 30, 40, 50. So this is your displacement. And it is in meter. And time is in second. So x-axis represents time. Now you have to plot different points. So point is given 0, 0, then 1, 10, right? So this is 1, 10. Then 2 and 20. So how do you plot? 20. Here. This is 2 and this is 20. Correct? Then you have 3 and 30. This is how you. 4 and 40. 5 and 50. So now when you join these, then you will get a straight line. Okay, this is what it is. So A part is on draw displacement time graph and with its help, find whether the motion of the car is uniform or non-uniform. Is it uniform?
Yes.
Why?
Because the line is time and the displacement is the same.
Because it is straight line. Graph is straight line. Straight line ST graph means it is uniform. You know? So nature of graph is since ST graph is a straight line, it means motion is uniform. Understood? So just by looking at the graph, you can tell whether it is a uniform motion or not. And also mathematically, every second it is covering 10 meter. Every second it is covering 10 meter. Correct? Every second it is traveling 10 meters. So it is satisfying both the depth. Now use the graph to calculate the velocity of the car. कैसे निकालोगे velocity? P part. So velocity, how do you calculate? You calculate by finding the slope. How do you find the slope? We select any 2 points. Okay? So let us say I select point A and point B. Let's say I select any 2 points. So what is this point? This is my x2. Okay, the point on the graph is x2 and x1. Why this is x1? Because this is my initial time, t1, and this is my final time, t2. So basically what I want is, I want to find this change. What does this distance give me? This is the distance. 50 minus how much? 20. And what is T2 minus T1? T2 is 5. 5 minus 2. Okay, this is what it is. Understood? So I could have selected any point. So corresponding point will be x2 or x1. Okay. So what is it? So this is x2 minus x1 upon t2 minus t1. So in this case, 50 minus 20 upon 5 minus 2. This is 30 by 3, which is 10 meters. Again, the same thing, 10 meter per second. Got it? So this is the velocity of the car. You have to find the displacement of the car at t equal to 2.5 seconds and t equal to 4.5 seconds. Second, you have to find displacement. So displacement of the car, matlab s at t equal to 2.5 seconds
And 4.5.
and s at equal to 4.5 seconds. So tell me, look at the graph and tell what is 2? There is 2.5 seconds.
Between 2 and 3.
So it is here.
Yes.
So
Exactly.
on the graph, take it. And from here you project here. So how to find the corresponding value? You take the projection, right? What is the displacement we are getting? Between 20. So this is 25. So the answer is 25. What is the unit? Meter. हाँ, and 4.5 second यहाँ पे आएगा बीच में. So if you know how to work with graphs, so from one value you can find the corresponding value, and this is how much? 45. Okay, so there are many graph-based questions possible, and it's not difficult. You just need to know the technique how to find. So basically, graph में तुम्हें slope निकालना है. तो ST graph में slope will give you velocity, और VT graph होगा तो उसमें slope will give you acceleration. ठीक है? Is this clear?
Yes.
So we have completed with this displacement time graph. Now we'll begin with velocity time graphs. Okay. Let's start. Okay, this is question from your volume only, so I am erasing it. समझ आ गया? और कोई question? Online students, do you have any question? Vivaswat and Manasvi.
No, sir.
Manasvi, am I audible to you, Manasvi? Is she there? No response. Okay. Okay, let's now discuss acceleration, velocity time graphs. I will draw the graph and you have to tell me what information the graph is giving. Okay. Let us say I have a velocity time graph like this.
Uniform velocity.
Uniform velocity. Huh?
Yes.
Is it too cold now? So V is constant, right? V is constant. That means constant velocity means uniform motion. Correct? So this is uniform motion. Since V is equal to constant. Now second VT graph is this. So this is not a graph for body at rest. If it was ST graph with this parallel to time axis, that would have been body at rest. But for VT graph, if the graph is parallel to time axis, it means uniform motion. Okay, VT graph में uniform motion, ST graph में uniform motion was like this. Okay, we just saw this. Now in VT graph, if you have a graph like this, what does this tell you?
It is constant. Velocity is constant.
Velocity is constant. Then what is here?
It is also.
It is also constant. This also velocity is constant.
Ah.
Time is increasing. Time is increasing. With time, is velocity same or increasing?
Increasing.
Then how it is constant? How can it increase also and remain constant also?
Acceleration is.
Yes, the slope is constant. What is constant here? The slope. But slope for VT graph is acceleration. Okay, so this is uniform. Whatever is constant becomes uniform. So uniform acceleration. Okay, so in this case, what is the acceleration? So A is the slope. Acceleration is equal to slope. And this is equal to, what is it? What is it? This is V2. This is V1. This T2. This T. So this is change in velocity upon change in time. Change in velocity upon time is acceleration. Correct? So this is average acceleration. Okay. So slope is constant. Why slope is constant? Because it is straight line VT graph. So if I select any 2 point, I will get the same answer. So it's repetitive, right? So now if you have what you have? Curve. I have VT graph, the curve now. So what is the unit of V? Meter per second. Meter per second. What do you have? You have this kind of a graph. Similar looking graph. अब यहाँ पे क्या information मिल रहा है?
Acceleration is not constant, but velocity
Is constant. If acceleration is there,
both of
therefore,
them is not constant.
exactly. This is changing acceleration. So non-uniform acceleration. This is non-uniform acceleration. Good. So now you are able to figure out. Similar looking graph, but it conveys different information. Okay? Non-uniform. Understood? So what is the slope here? Here the slope was constant. Is slope constant here? Let us say if I take 3 different points. Is the tangent at every place, every point constant?
No.
Tangent will make different angles.
Yes.
So slope is increasing. So it is a case of
possible straight line, straight line graph.
that becomes infinite acceleration. Straight line का मतलब क्या हुआ? Infinite acceleration. Zero time interval में velocity is increasing like anything. So ऐसा नहीं होता.
Teleportation.
That is a thought experiment. Physically, teleportation still is a dream. Is it possible?
No.
It is only thought experiment, right? So this is what it is. ठीक है? तो यहाँ पे भी, if you calculate, if you join these two lines, it will be average acceleration between these 2 points. Because now the acceleration is also changing. You can calculate average. You can find instantaneous acceleration. If you find the slope of the tangent at that point. Okay, is that clear? So what you are seeing is the nature of motion. Okay, the first row is nature of motion, and in these 3 graphs it is different. Uniform motion, uniform acceleration, non-uniform acceleration. This is the nature of motion. What is the second information the VT graph gives? Slope of VT graph gives acceleration. Because this is the second thing. Slope of that VT graph, that is A is equal to x2 minus x1 divided by V1. Sorry, is it x2 minus x1? V2 minus, this is a VT graph. Select any 2 points on the VT graph and you can calculate slope from this. It also gives one more thing. What does it give? Area under VT graph gives displacement of the body. Okay? Area under VT graph gives displacement. In chosen time interval. Okay. Okay, you can write this down, whatever I have written. Because VT graph, we were to start. Last class we had finished ST graph. So write down all these 3 things. So there are 3 information that a VT graph gives us. Okay. What are the information provided by VT graph? Nature of motion. Slope gives acceleration. And third, area under the VT graph gives displacement. So I will explain this. First you write
The
it.
boring case here.
That is acceleration time. That's a different graph. Yeah. वो तो नॉन यूनिफॉर्म है ना, कोई भी कर्व जहां पे भी है वो नॉन यूनिफॉर्म, खाली ये 2 स्टैंडर्ड ग्राफ है, ये कर्व है, इसके बाद तुम कुछ भी ले लो ना वो तो नॉन यूनिफॉर्म ही आने वाला।
सर
हाँ, अभी ये कुछ भी बना दो नॉन यूनिफॉर्म है।
तो ये इम्पॉसिबल,
हाँ
ये भी इम्पॉसिबल ही होना चाहिए, स्ट्रेट लाइन है।
यार इसका स्ट्रेट लाइन है,
इंक्रीजिंग तो बैलेंस्ड है, बट नीचे आता है एकदम स्ट्रेट है,
एकदम शार्प टर्न, लाइक फ्री फॉलिंग ऑब्जेक्ट, फ्री फॉल। फ्री फॉल में क्या हो रहा है, वेलोसिटी 0 हो रहा है ना,
बट 20 मीटर फ्री फॉलिंग का
60, इट्स लाइक
पॉइंट सर
listen, कहाँ पे? Yeah, you draw everything relative. So, ये कौन सा केस है? Suppose I am running very hard, collide with the wall. क्या होगा?
एक्सेलरेशन 0 हो जाएगा,
Velocity क्या होगा?
वेलोसिटी 0, वेलोसिटी कम हो जाएगा,
Suddenly 0 होगा ना, 0 हो गया ना, 0 से पहले क्या था मेरा वेलोसिटी?
5
60 ना, ये वाला ग्राफ है ना,
इसमें हाँ 65
65 पे था
हाँ
और मैं कोलाइड हो गया, वहीं 0 हो जाऊंगा ना मैं तुरंत,
ओके
समझ आया? वैसा है। सो ये कोलिजन के केसेस में ऐसा होता है, सडन वेलोसिटी चेंज होगा, जहाँ पे कोलिजन हो ऐसा हो रहा है, यहाँ पे ट्रक खड़ा है और एक कार आ रही है हाईवे पे, साइड पे पेवमेंट पे ट्रक खड़ा, उसको ठोको तो फिर घुस गई ट्रक, वहीं रुक गई, ट्रक तो वहीं है, कार वहीं रुक गई, ठीक है? तो कोलिजन के केसेस में होता है।
Just say for example I am skydiving and like for example I am falling at 50 kilometers an hour
Okay.
speed and once I deploy my parachute my speed decreases.
Yes.
So how will I show that speed graph?
So you figure out when the velocity is increasing. देखो शुरू में क्या होगा, टाइम के साथ दिखाओ ना, time will keep on increasing, correct?
Yes.
Time will keep on increasing. Initially your velocity will increase
Yes.
Let us say at time t equal to 0, what was your velocity when you are still in the plane? You are yet to take the jump. तो तुम्हारा velocity 0 है, तुम अभी ऐसा है. अब suddenly increase होते जा, acceleration क्योंकि तो तुम्हारा velocity कैसा होगा? ऐसा आएगा. Velocity is not uniformly increasing. What is uniform? Acceleration.
Acceleration.
So acceleration. So अगर ये vt है, अगर ये vt है, तो vt है तो क्या होगा? Acceleration uniform है, तो straight line आएगा.
Yes.
Increase होते जा रहा है तुम्हारा velocity. उसके बाद क्या हो गया?
When I deploy my parachute, my speed decreases.
हाँ, speed decreases. तो ये क्या होना चाहिए फिर? तो ये ऐसे हो जाएगा. लेकिन ये decrease कैसा होगा?
Slowly.
हाँ, ऐसा. Slow and steady. Still the velocity will increase for some time, but finally it will get steady. तो ये ऐसा हो जाएगा. उसके बाद imagine you will like now what will happen? You will come down at a constant velocity. तो तुम्हारा velocity क्या होगा? Constant होगा. So it's like you are moving, but now with a constant speed.
तो ऐसे जा रखी है ना मेरा.
Right?
Or
What is reducing? The acceleration is reducing, ना?
the
तो acceleration में reduce हो रहा है, मतलब slope कम हो रहा है. तो slope 0 हो गया.
फिर एक्सेलरेशन कम भी तो होगा ना.
हो गया ना, कम हो गया तो 0 हुआ. ये acceleration था उसको. यहाँ तक acceleration था. अब slope क्या हो रहा है? कम हो रहा है. Slope ही तो acceleration है. Slope ही तो acceleration है भाई. Slope खत्म हो गया, यहाँ पे 0 हो गया slope. अब acceleration है ही नहीं. अब वो यूनिफॉर्म वेलोसिटी से चल रहा है. वेलोसिटी टाइम ग्राफ है ना ये. डिस्प्लेसमेंट थोड़ी है कि नीचे आएगा. कौन सा ग्राफ है? फिर कांस्टेंट वेलोसिटी से ही वो ग्राउंड को हिट कर देगा. तो थोड़ा तो थट लगता है ना तुमको. तुम्हारा वेलोसिटी कुछ है, फिर सडनली 0 होता है. तो तुम जब ग्राउंड पे आओगे, चाहे जितनी भी देर में आओगे, तो सडनली तुम्हारा वेलोसिटी 0 हो जाएगा. इसलिए तो चोट लगता है ना. इसलिए क्या बोलते हैं, लैंड होने पे भी की बैंड करके भागने बोलते हैं, और फिर धीरे धीरे वेलोसिटी रिड्यूस करने बोलते हैं. फिर पैराशूट पीछे गिर जाता. अगर तुम पैराशूट लेके सीधे वैसे ग्राउंड हिट करोगे तो पैर टूट जाएगा.
The speed is still like at a speed that it will break my bones.
Obviously 10 किलोमीटर पर आवर भी है अगर समझो, that is also a good speed. When you are walking, it's like when you are walking, okay, and you hit the pole, बीच में चोट लगता है, that's a good speed. It could be lethal also if it hits the bad spot. है ना. तुम ऐसा चल रहा है, कोई बीच में खड़ा है, उससे भी टकरा जाओ तो काफी चोट लगता है. What is your speed? ठीक है. तो वैसा है. When we study about momentum and all in the forthcoming chapters, it will become more clear. When we study about force, the impact अभी तक पढ़ा नहीं हमने. अभी तो हम मोशन ही सीख रहे हैं. नेक्स्ट चैप्टर में इम्पैक्ट है. Is this clear?
Yes.
Okay. Have you noted down? So these two cases are non-uniform acceleration. Whenever the graph is not a straight line, it is a non-uniform acceleration. So this is meter per second, and this is second. So we have completed velocity time graph, right? So the third case I need to discuss little more. Let me know when you have finished all the graphs. Let me put some values here. So let's say 10, 20, 30, 40, 50. ठीक है. So if I want to ask you how much distance the object covered from 2 to 4 seconds.
40, 0.
Okay,
0 meters.
0 meters. 0 meters, 2 to 4 seconds. So 2 to 4 seconds it traveled at the rate of 40 meter per second. Means every second it covered 40 meters. So total is 80. 2 seconds में देखो तो 80 कैसे आया? For 2 seconds you know that it traveled at the rate of 40 meter. हर second में 40 cover कर रहा है. तो displacement कितना होगा? 80. So how did you get it? What is this? What is this? 4 minus 2. And what is this? 40. This is 40 meter per second. And this is 2 seconds. Isn't it? 4 minus 2. So is it not the area? 40 into 2. What is 40 into 2?
80.
80, which is the area. So therefore, acceleration is v by t. Change in velocity into time. Okay. And what is velocity? Displacement upon time. What is displacement? V into t. V into t is displacement. Yeah. So in this, how we are getting V into t? This is the rectangle. This is V into t. Area of rectangle gives V into t. Area of rectangle is product of velocity into time. And what is velocity into time? Displacement. Correct? That's why area under VT graph gives displacement in the chosen time interval. So if I ask you, what is the total displacement covered by the object in 4 seconds?
40.
Huh?
40.
4 seconds में
240.
80.
240 meters.
area निकालो.
Between.
अरे 160 sorry.
160. Correct? Area under VT graph. You get it? Don't go very fast. समझ के करो. ये तो mistake हो जाए. ठीक है?
8
हो जाता है. तो it's fine. But you understood the concept. Have you understood the concept? What is the concept? This is the concept. Area under VT graph gives displacement covered by the body is in. What is it? Look for my grammatical and spelling error. Sometimes I will eat the word itself because while speaking I say, but sometimes I jump the words. Okay? So just mark for. Keep a watch on that. So what do we get? Displacement is, since V is equal to S upon T, this means S is equal to the product V into T. So in the graph, in the VT graph, the product V into T gives displacement. And how do we get the product? By area. Okay. Now let me give a twist.
Yes, sir.
The twist is this. Now let us say I have this graph. So I have 1, 2, 3. So you have 5, 10, 15, 20. क्या हो गया? ठीक है, यही हो गया. 15, 20, 25 and 30. Okay. I want you to find out. Is it correct? It is a straight line. 2 में 15 जाएगा. B में कितना जाना चाहिए इसको? नहीं, graph is not correct. Wait. This is 10, 20, 30 ले लो. हाँ बोलो. Okay. Now, what is the displacement for this graph? Find between 1 to 3 seconds. In 3 seconds. Find the displacement.
Displacement.
Which graph is this? What kind of graph is this? VT. And how do you find displacement in a VT graph?
V into T.
By finding the area under the graph in the chosen time interval. Okay. So what is the time interval I am giving you first?
1, 2, 3.
Between 1 to 3 seconds. Not 1, 2, 3.
1, 2, 3.
That's the time interval. Okay. So what's the area?
So 10 to 30.
What is the area? It is making a trapezium now. So it will be area of trapezium. Okay. So in the first, it will be equal to area of
Trapezium.
trapezium. What is it? Half into sum of parallel sides. Sum of, this is parallel side, not 11 sides. Into,
Sir, okay,
into, what is the area of trapezium? Sum of parallel side into distance between them or height.
height.
Into
Height.
height. अब यहाँ पे height नहीं है, यहाँ पे क्या है distance है. Correct? What is height of trapezium here? It's not this, it's this.
Height of trapezium is.
You say distance between parallel sides. Okay, what do you say? Distance between parallel sides.
Sum of parallel sides. 10 plus 30.
So how much is this? Half. What are the parallel sides?
Distance 2 seconds later.
Huh?
Distance between parallel sides का 2
Yes,
seconds.
yes.
So
क्योंकि
2
टाइम देता है ना वो.
2.
B into T. ये तुम्हारा क्या हो गया? Velocity.
Then the 40 into 2.
So what is velocity here?
40.
This side is 10 meter per second and this side is 30 meter per second.
40.
Yeah, 10 plus 30, right? Full 10 plus 30. And this is
2.
2. 2 कट हो गया. क्या आ गया?
40.
So 40 meter per second नहीं. We are calculating what?
40 meters.
Displacement. S. कितना आएगा? This was in second. This was in meter per second.
Sir, अगला है triangle.
तो जरा चुपचाप रहे और ज्यादा जल्दी भी आगे मत भाग.
Sir है.
रुक एक मिनट. सुन पहले मैं क्या बता रहा हूँ. ठीक है? जब तक क्वेश्चन नहीं मुझे बोलना नहीं है. तो पहले हमने इसको कैसे निकाला? एरिया ऑफ ट्रेपेजियम निकाला. ठीक है? इसको और एक मेथड से कर सकते हैं. कैसे? यहाँ पे दो एरियाज हैं, 1 and 2. तो ये दोनों एरिया भी ऐड करने से आ जाएगा. सेम आंसर आएगा. हमने ट्रेपेजियम लिया तो पूरा एरिया एक साथ आ गया. यहाँ पे एरिया ऑफ रेक्टेंगल प्लस एरिया ऑफ ट्रायंगल करेंगे तो भी आंसर आएगा. ठीक है? देखो इसको बाद में निकालेंगे. ठीक है? ऑल्टरनेटली इट इज इक्वल टू मतलब 1 to 3 सेकंड में एक तो हमने एरिया ऑफ ट्रेपेजियम से निकाल दिया, दूसरा क्या है एरिया ऑफ रेक्टेंगल, ये क्या है लेट्स नेम इट ए बी सी डी ई, है ना। यहाँ पे ट्रेपेजियम क्या था, एरिया ऑफ ट्रेपेजियम ए बी सी डी ई, रेक्टेंगल क्या है ए बी डी ई प्लस एरिया ऑफ ट्रायंगल बी सी डी, ठीक है। तो रेक्टेंगल का एरिया क्या आएगा यहाँ पे ए बी इंटू ए ई प्लस व्हाट इज एरिया ऑफ ट्रायंगल हाफ बेस, बेस क्या है बी डी इंटू हाइट इज सी डी, ठीक है। दिस वे ऑल्सो वी कैन कैलकुलेट, सेम आना चाहिए आंसर। So what is AB into AE? AB is 10. What is this? Meter per second. Into what is AE? A is 3 minus 1, 2. This is 2 seconds. Plus. ये समझ में आया स्टेप? What is AE? यहां से यहां जाओगे तो 2 ही सेकंड हुआ ना, 3 minus 1. समझ आया? AE कितना हुआ? What is AE? हाँ?
3 minus
3 minus 1, 2 seconds. है ना, इंटरवल ले। वैसे ही अब आगे निकालो 1 by 2 into BD. BD is also equal to A, rectangle. ये कितना हो गया 2 seconds. What is CD? CD is 30 minus 10, which is 20 meter per second. ठीक है, ये खत्म हो गया, सेकंड पर सेकंड के साथ खत्म हो जाएगा। यहाँ क्या बचा मीटर, यहाँ पे भी सेकंड will get cancelled with per second. Second by second is 1. ये हो गया 20 मीटर plus 20 मीटर. This is 40. So why I showed you this is, right? We are going to use this concept later to derive the equations of motion. ठीक है? So either ways you calculate the area under the chosen time interval, you are going to get the same displacement. Both answers are same. Clear? Is this clear? Now, if I would have chosen find the displacement covered in 3 seconds, then what is it? It is half base into height, only triangle, like he said. Okay. So it will be what? Half base, half into 3 into height is 30. Half 3 into 30. Clear? वैसे वो निकल जाएगा, तो निकालो उसको सेकंड वाला। अभी समझ में आ गया?
45 meters.
अभी समझ में आ गया? So there are alternate ways to calculate area. You just divide, just geometry, nothing else.
45 meters.
Second वाला 45. ना हो गया? S in 3 seconds. From this graph, S is equal to area of triangle. इसको तुम O मान लो, ठीक है? OCE. OCE. ठीक है? Assume this is letter O. So this is half. Base is OE into EC. What is OE? 3 seconds. EC is 30 meter per second. कितना हो गया? This is 0.5 or 90 by 2, whatever, 90 by 2. This is 40. ठीक है? So if you have a VT graph and somebody wants you to calculate the displacement for whatever time interval is asked for, You just calculate the area. So we have seen 3 cases. Understood? Any questions here? Okay, Nicholas. Okay. And example 7 will be homework for you. Because we have done enough. So you can take it as a homework. This is page number 24. You writing? So wherever there is graph, become a ritual of drawing it. क्या वैसे बोलने बैठता है क्या? कहाँ है तेरा notebook? ले इसको. Are you maintaining a homework notebook? Yes. अलग से बनाओ नहीं तो इसमें ही अलग से लिखो homework. ठीक है? We discussed that, right? In the beginning, did I discuss?
No.
Okay. So first note it down, then I'll discuss. To write all these formulas, this will be useful. You can draw the graphs one below the other. साथ में अगर नहीं हो रहा है तो one below the other is done. Does anyone has any doubt? बस ये स्टूडेंट बोलिए. This S, everyone understands, right? S is displacement. ठीक है? बताओ,
सर सेकंड अल्टरनेटिव में
क्यों नहीं लिखा?
सर फर्स्ट वाला ECS
Alternatively भी करो, because there is a reason why I have given you this. I erase the first part. Alternately, what is equal to? S is equal to. S. Completed? समझ में आ गया? So अपने पास दो ही ग्राफ है, ठीक है? एक थर्ड है एक्सेलरेशन टाइम ग्राफ, which is very simple. That also I'll start. Shall I discuss? So just like ST graph, VT graph, let us plot PT graph. So y-axis is A. Y-axis represents acceleration. X-axis represents time. Now acceleration is, let us say this. Okay, this is my AT graph. What is the nature of motion? What is the acceleration?
Zero.
Yes.
Velocity is zero.
Acceleration zero, so velocity zero. Always. What if the velocity?
पोजीशन में वही है.
कैसे? भी यूनिफॉर्म भी तो हो सकता है. कांस्टेंट वेलोसिटी में मोशन क्या है? Can a body move with zero acceleration?
No.
No. If v is constant, what does this tell you? A is equal to zero, but v may be constant. So the state of motion could be uniform motion.
For example,
सारे all the uniform v constant. अरे जब ये वाला एग्जांपल है, ये क्या एग्जांपल? इसमें तुम्हारा v क्या है और a क्या है कि नहीं? इसमें वही तो है और क्या, बट अभी ग्राफ क्या हो गया? 80. ठीक है? So this graph depicts uniform motion. ठीक है? अब एक दूसरा ग्राफ लेते हैं. What graph is this? Is A 0 in this case? Is A 0 in this case? And what is this? Is A 0 or it has some constant value?
It has.
A equal to constant? What motion is this? Uniform? Uniform acceleration. This is uniform acceleration. In case of VT graph, it was a straight line. Okay. So depending upon what the variables are representing on y and x axis, the information conveyed is different. Okay. Now there is one more acceleration time graph. Let us say you have what is this? What is this? In VT graph, we forgot one case. Due to variable. If this was VT graph. What was this graph?
Velocity reducing.
So what does it mean?
It's the
Slope is
negative.
negative acceleration means
Means the speed is decreasing.
retardation. This is a case of retardation. This is A,
Retardation.
A is negative. Brakes applied. A negative means the final velocity. What is the final velocity? Look here. There are so many things I want to tell you, but sometimes you speak out of turn and destroy the momentum. Pehले सुनो, be an attentive listener. Okay, I'll give you enough time for you to ask questions, but let me first speak whatever I want to. Okay. So this is now a negative slope. Negative VT graph, negative slope VT graph means acceleration is negative. And what is negative acceleration? Retardation. We have discussed that. Haven't we? Have we discussed retardation?
Yes.
Yeah. So this is a negative slope. Slope is negative. So what is this graph now? Here A is it is, and is it uniform retardation? And this is constant negative acceleration. This and this graph are same. Okay, so what is this graph? Uniform retardation. Okay, so we have got three AT graph. The first line, so the nature of AT graph convey. What do they convey? The nature of motion. Whether it is uniform, whether it is uniform motion, uniform acceleration, or uniform retardation. And second, what is the area of AT graph? What is area of AT graph? क्या होगा? What is this area? Acceleration into time. And how much is that? it is equal to V2 minus V1. Area of AT graph is, it gives difference in speed in the chosen diameter. Okay. So this is equal to V2. So difference in velocity. Area of AT graph gives difference in velocity. वही तो है, क्योंकि फॉर्मूला क्या है? क्या था फॉर्मूला एक्सप्रेशन का? B minus U by T ये होता है ना? So AT equal to क्या? B minus U. इसका एरिया प्रोडक्ट ऑफ एक्सेलरेशन टाइम. अगर मैंने यहाँ तक लिया, if I put some value, if I put some value, whatever is the area is nothing but the difference in velocity. If the object was accelerating, then its velocity will increase to this way. From where? From wherever, from the start. Is that clear? Means increase in velocity. This gives difference of change in velocity or increase in velocity. If it is accelerating, if it is retarding, then it will give decrease in velocity. See how fast she is going. Okay. Write down these graphs before leaving. 2 minutes. I mean, go smartly, close them and go home. Then next class मैंने ask क्या किया था वो पता ही नहीं किया. इसलिए तेरे को पता नहीं क्या किया. जैसे ही बंद हुआ लेक्चर खत्म, भागो. बहुत स्वीट तो नहीं है? हाँ? Dark. Just like you. Are you a dark personality? Dark matter. Universe is made up of mostly dark matter, right? Luminous bodies are in points, but most of it is dark. So what have we learned today? So we everybody is in hurry. Everybody is in hurry. I don't know. Nobody wants to die so fast. Everybody wants to live. Then why hurry? Done? ठीक है. तो ये वाला हमने ग्राफ छोड़ दिया था, मिस किया था, उसको भी चाहे तो लिख लो और else we discuss it next. लिखिए वो. All right, I'll do in the next.
कोई भी साइन नहीं है. मेरी पेरेंट्स की साइन नहीं है. मेरी साइज. मुझे साइन नहीं है पेरेंट्स.
कौन करेगा? सर करेगा.
हेलो. मुझे